Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I welcome you all to the class of real analysis. In the last couple of lectures, I discussed about smallest and largest element of set. If you have no knowledge about smallest and the largest element of set, you can watch my previous lecture. In today's video, we will discuss a problem that is much similar to the last problem that I discussed in the last lecture. In today's lecture, we will discuss a problem. We have given a set B that consists on all those rational numbers which are positive and whose square is greater than 2. We need to show that the set B has a no smallest element. If you have no concept about smallest element, you firstly watch my previous lectures. To show B has a no smallest element, for this we will use the contradiction. Let us suppose on the contrary that M is the smallest element of B. We suppose on the contrary M is the smallest element of B. So if M is the smallest element of B, then as every element of B satisfies the three conditions, every element of B satisfies three conditions. First condition is that should be positive, that should be rational, and the square of that number should be greater than 2. So if M is the smallest element of B, then M will belong to Q, square of M will greater than 2, and third one M will be positive. To prove the theorem, we will show that for every M belong to B, we can find an N such that N belong to B and N is less than M. As above, we have supposed M is the smallest element. To prove this, that our supposition is wrong, we find another element N that also belong to B and that element is less than M. For this, we construct a number N by the help of M such that N is equal to M minus M square minus 2 over M plus 2. You can notice that the second number, that is M square minus 2 over M plus 2, is here a positive quantity. How? As M is the element of B, we have supposed. So square of M will be greater than 2. So here M square greater than 2 implies M square minus 2 will be greater than 0. As M is also positive itself, so when we divide M square minus 2 by the number M plus 2, this will be also positive. So M square minus 2 over M plus 2, this fraction will be positive. Now this number, that is here N is equal to M minus some positive quantity. From here N will be less than M because N is the difference of these two numbers. For example, like as we say that 3 is equal to 8 minus 5. So here 3 is the difference of 8 and 5. We can observe that obviously 3 is less than 8. So in the similar way, here N is less than M. So the first requirement is complete here, that is N is less than M. Next we show that N belong to B. If N belong to B, for this we will show that N will satisfy three conditions, that N should be a rational number, that N belong to Q, N should be positive, and N square greater than 2, because every element of B has a three properties. It should be positive, it should be rational, and its square should be greater than 2. So here, to show that N belong to B, we will show all these three conditions. So firstly we show that N is positive. First we show that N is positive. Here n is equal to, we have defined n is equal to m minus m square minus 2 over m plus 2. By taking LCM here, this will become m square plus 2m minus m square plus 2 over m plus 2. In the numerator, m square will be cancelled. This will become 2m plus 2 over m plus 2. By taking 2 as a common from the numerator, this will become 2 into m plus 1 over m plus 2. As here m is a positive rational number, because at the start we have supposed that m is an element of B, so that's why m will be positive here. So if m is positive here, then obviously m plus 1 and m plus 2, both numerator and denominator will be positive here. So finally this fraction is positive. Now this fraction is equal to n. This implies n is greater than 0. So the first task is complete here. Next we show that n belong to Q and n square greater than 2. As m belong to Q, m is a rational number, and we know that some product quotient of a rational, two or more rational number, is again a rational number. So as we have defined, n depend on m, and m is itself a rational number. So by using this result, that the sum product quotient of rational number is again a rational number, we have n is also a rational number. This implies n belong to Q. So the two tasks have completed here. Next, lastly, we will show that n square is greater than 2 here. Now finally we show that n square is greater than 2 here, or in other words we will show that n square minus 2 is greater than 0. So we will show that n square minus 2 is positive here. From the last page we can notice that after taking LCM, n is equal to 2 into m plus 1 over m plus 2. So by taking square in this step, we have n square is equal to 4 times m plus 1 over m plus 2 whole square. By opening square here, we have 4 times m square plus 1 plus 2m over m square plus 4 plus 4m. By subtracting minus 2 on both sides, because we need to find n square minus 2, we have to show that n square minus 2 is greater than 0. So by subtracting 2 from each side, we have, by taking LCM, after taking LCM, we have the expression 2 into m square minus 2 over m plus 2 whole square. As here, m square is greater than 2. Why? Because at the start, we have supposed that m belong to B. That's why m square should be greater than 2. This implies m square minus 2 is greater than 2. And m plus 2 whole square is always positive, because m is already positive here, square is also positive. So the numerator and denominator both are the positive number. So their this fraction will be positive here. This implies n square minus 2 is greater than 0. So by using here n greater than 0, n belong to Q, and here n square greater than 2. From all these three, we have n belong to B, because n will be an element of B if it satisfies these three conditions. It should be rational, it should be positive, its square should be greater than 2 here. Also, we have proved that n is less than m. So n is an element of B, and also n is less than m, and at the start, as because we have supposed that m is the smallest element of B. Here we find another element of B that is smaller than m. This shows that B has no smallest element. That is, our supposition is wrong. Hence, prove the result. I hope today's lecture is helpful for you. Inshallah, we will discuss a new topic in the next lecture. Okay, take care. Allah Hafiz.